Hello and welcome to lesson 4.3, measurement calculations in 2 dimensions. First of all, recall that the term perimeter is the length around an object, whereas area is the space inside of an object. We often use the term A to represent area and P to represent perimeter. You can also use subscripts to specify what type of perimeter or area of what shapes you're using. Now let's look briefly at some perimeters and areas that you should know from the grade 9 EQAO formula sheet. So I'm going to look at this on my iPad here with you. We're going to go to the courses here. We're going to look at our course specifically under content. Going to Unit 4, Geometry and Measurement. And we're looking at lesson 4.3. So in 4.3, you will see the grade 9 EQAO formula sheet. So we're going to open this right here. So some shapes that you should know. Rectangles. You should know a rectangle. Over here, you are given the perimeter and the area. Parallelogram you may not know, but this is how you work out the perimeter and the area of the parallelogram. Triangle, you should know. Trapezoid, you may not know. A circle, if you're unaware, this is how you calculate the perimeter, which is often called a circumference, and the area of a circle. Some other shapes that you might know, and we'll get into this in three-dimensional shapes later on. You might know the surface area and the volume of a cube. Should also know that surface area and volume of a rectangle and a triangular base prism, as well as a cylinder. We'll go over these a little later as well. Okay, so I'm going to close these. I'm going to go back to our lesson. Okay, so we're going to use these to determine composite shapes, or parameters and areas of composite shapes, which are basically shapes, multiple shapes added or subtracted from each other. So first off, we can find out the perimeter and area of any regular polygon. So right here I have a regular pentagon being drawn. And I have two other measurements. One called the side length, which is given by this value S, and another one which we call our apothem. It's kind of like a radius of a shape. Well, what you can do is you can actually take this apothem, because it is kind of like the radius, and it's halfway through the shape. You can actually create a number of different triangles. And what you'll notice is all these triangles should be the exact same size. So to figure out the perimeter of any regular polygon, where we're going to let n represent the number of sides, to calculate the perimeter, all you have to do is take n, the number of sides, and multiply by each side length, s. To figure out the area, since we have the number of triangles being the same number of sides that we have here, we're going to use n again. And each triangle you can find the area of. So the area of each triangle, you can find the side length times whatever the apothem is, and divide by 2. In other words, that whatever the base is times the height divided by 2. So these are some general formulas you can use in order to find the area of any regular polygon that you may wish to find, if it's not made up of shapes that you do know. Okay, so let's take a look at another shape right here. So we're going to calculate the area and perimeter of this following shape right here. This is not a regular polygon, as it does not have the same side lengths everywhere. Okay, to find the total area of this, you might notice that this rectangle right here and this rectangle right here are the exact same size. You can see these two dashes right here, here, and here, and here, meaning they are exactly the same length or width. And you can also see these three dashes right here and here, they're the exact same size as well, meaning that these two rectangles are exactly the same size. The only other thing right here is a triangle, which I'm going to label 2. So to find out the total area of this shape, we need to find out the area of 1. So to find the area of 1, it's a rectangle. And to find the area of a rectangle is just length times width. So that it works out to be 11.76. Now if we also want to find the area of the triangle, we take the base, which is 0.9, times the height, which is 2.8, take that answer and divide by 2. So our total area and you can put this all together in one expression if you wanted to, is the 11.76, because there's 2 of them, and we add 1.26. So this turns out to be 24.78 centimeters, because this is area squared. So there's the total area. Well, you might also notice we don't have one length. We don't happen to have this length right here, which I'm going to call C. But we do have its base and its height. So to figure out C, we can use Pythagorean theorem. To figure out the value of C. So my value of C is approximately 2.941. Now, in order to figure out my total perimeter, all I need is the outside edges, which I'm drawing here in red. You don't need the inside edges, so we don't need to include those sizes. So to find my total perimeter, I have to take this value 2.491, add, let's see, I have 3 values of 2.8. I have 2 values of 4.2, and I have 1 0.9. So if I use my calculator, I get this to be 20.641, and because this is only a length, this is centimeters. Don't forget to use the units at the very, very end. Okay, let's take a look at this shape. Here we want to calculate the shaded area of this given shape. You might notice that this shaded area is actually a rectangle with two circles removed from it. So that's what I'm going to write out. My shaded area. Oops, I'm going to write it this way. Area shaded is equal to my area of my rectangle minus 2 times the area of two circles. Well, in order to figure this out, I need some other lengths here. So because this is two circles, we're going to assume each circle has a diameter of 3.2 centimeters. And that means this length will also be 3.2 centimeters. And that means our radius will be 1.6 centimeters. So now I have enough pieces of information to fill this one out. So the area of my rectangle can be calculated by 6.4 times 3.2. My area of a circle is given by pi. Pi is this symbol, times the radius, which is 1.6 squared. Now, if you're going to replace the value of pi by 3.14, instead of writing down pi, you write down 3.14. Pi is the actual value on your calculator you can find, but if you are going to replace it with 3.14, you have to actually replace it with the value 3.14 and use that calculation instead. So using my calculator, I'm going to plug this, and I get approximately 2.438, and as this is an area, centimeters squared. Again, you do not need to show each step or value as you work this out. And thus concludes this lesson.